Well, welcome to the stream, friends. Hello. Hi. Welcome. Another wonderful day. My stream just died. Maybe it didn't. Got my little monitor here, also known as my cell phone. Stopped working, but I think we're back now. Let me make sure that my sound is good. I think we're good. I think we're good on the sound. All right, thanks for tuning in. If you're new, then welcome. Welcome if this is your first time tuning in. Welcome back if you have if you've been a previous viewer of the stream. Thank you for dropping by, coming by again, I guess. It's a pleasure to have you, everyone. So this is my Twitch stream. I have been working on a series called Cracking the Coding Interview with Rust. So we are going through this book. It's called Cracking the Coding Interview, written by Gail Lockman McDowell. There she is. She is the author. She is a computer genius, according to her bio here. That's what it says. Just kidding, it doesn't say that. But it is kind of, you know, I guess everybody's bio's got to be a little bit boasty. Just the way it is. Anyway, so thanks for tuning in. Let's see. Let's do a quick review of where we are and where we were. Let me jump over here to my screen and hip up. That's Doge down there. Let's go to the project right here. So if you want to look at the code, follow along, you can go to my GitHub profile. It's just my name, Brenden Matthews, no vowels, / cracking the coding interview Rust, words separated by dashes. And you can check out the code, follow along. Yesterday we did chapter 4, problems 4 through 9. We did 5 problems yesterday. That's a decent number. There are, I think, 3 problems remaining in chapter 4. Yes, there's 3 left in chapter 4. That's where we are. I think we can probably finish these today. And maybe we'll even start on chapter 5. Let's see how it goes. Chapter 5 is about bit manipulation. Wowee, sounds really fun. Just glancing at it, it looks like that's going to be a pretty easy one. Maybe, I don't know. We'll see when we get there. So yesterday I did something a little different. Started off the stream just doing a little overview of what's happened recently in the Rust ecosystem. If you tuned in and you like that, let me know. I can keep doing that. I've been thinking about maybe trying to host a meetup or something in New York. I noticed that I did some searches. I'm not gonna do it right now. But I was surprised I couldn't find like a regular meetup event for Rustling in New York. So perhaps I can find someone who would be willing to host it, some space, and could organize something. Might be cool. Maybe some people would come to that. I don't know. Okay. Anyway, moving on. Let's talk about cracking the coding interview. Let's do it. Let's see. So chapter 4 is about trees and graphs, and all of the problems up to now have been, all of them have been almost the exact same theme, which is that they are all basically search problems, just like, you know, 101 different ways to do a depth first search, that kind of thing. So the next problem is called check subtree. Just glancing at it, looks like another search problem. Then after that, so problem 10 is check subtree. Problem 11 is random node, which is supposed to get a random node out of the tree. Okay. And then problem 12 is paths with sum. Okay. So let's do problem 10. Check subtree. Let's read the problem. What does it say? What does it say? Problem 10. Check subtree. T1 and T2 are two very large binary trees, with T1 much bigger than T2. Create an algorithm to determine if T2 is a subtree of T1. A tree T2 is a subtree of T1 if there exists a node n in T1 such that the subtree of n is identical to T2. That is, if you cut off the tree at node n, the two trees would be identical. Interesting, okay. Very large binary trees. T1 is much bigger than T2. Check if T2 is a subtree of T1. Okay, so again, this is another search problem. Seems pretty straightforward, although the language around it says two very large binary trees, and then it also says T1 is much bigger than T2. That wording is, I don't know, maybe it's a red herring, but it sounds like that's something, that's like some kind of hint suggesting that this problem is something that can be optimized in such a way that you don't have to search the whole tree, I guess, because I think, like, in order to compare if two trees are identical, you have to compare every single node in those trees, right? I believe that is true. I don't think there's a way around that unless, like, you have a hash of the tree or something like that. So I guess you just have to search the whole trees. So I guess the first part of the search is to simply find the first node of T2 in T1, see if that exists, and then if it does exist, then you would, if it does exist, you would have to compare all the nodes in that subtree to see if they are equal. Okay, so it also says that these are binary trees. It does not say that these are binary search trees, which means that they are not necessarily balanced, and we cannot make any assumptions about where things are in the tree. It just says binary tree. So up to now, I haven't strictly implemented a binary tree. We've implemented DAGs, like graphs, and binary search trees, but binary search tree, of course, is not strictly the same as a binary tree. That said, I'm just going to use one of my previous binary search tree implementations to do this problem because I don't want to reinvent the wheel, and the problem doesn't state that I can't use a binary search tree. It just says binary tree. A binary search tree is a binary tree. And I don't think it really makes any difference in this algorithm. Like the The actual algorithm and the problem will be the same whether it's a binary search tree or just a regular binary tree. All right, cool. Enough talking. Let's jump in. Let's jump in and do it. Let's see. I hope my stream is working. Well, I don't really know. I can't really tell. I think it's working. I checked the sound already, but yeah, cool. I think we're good. Dashboard is green. It says the stream is healthy. I think we're ready. Let's do this. So let me open up VS Code, which I didn't open yet. Let me make the font a little bigger in the terminal. I should save that. I have two profiles here for iTerm that I use, and I switch between the profiles. Whoops, I didn't want to uncheck that. Oh, that's right. I used 18 because it doesn't. Why does it not let you change the font size? Like, why can't I use 20 point? I don't know. Let's see how that looks. See, that's too big. I want halfway between this. I want this. I want this size. This is a log from this Python thing I wrote to delete my own tweets after 24 hours or whatever. You can configure it. Not at all related to this project. It's something I been wanting to write for a while, but we had a hack day at work. Here it is if you want to check it out. It's just called Tweet Delete. We had this hack day thing at work, and I decided to finish this project. Anyway, you can look at it if you want. I'm currently running this on my Twitter thing, so if you pay attention to my tweets, which you probably don't, then you may notice that they disappear after 24 hours, which is pretty sweet. Only if they don't meet my minimum engagement metric, which I think I have set to 5 now. But anyway, okay, let's not talk about that. Let's talk about this. And I can't fix the font here, which I want to do, but I can't because computers don't make things easy. Why can't I just type in a number? Why can't I just type in 20? It's really annoying. Size. Edit sizes. Oh, look at that. New size, 20. Why does it not just let you type it in? Why do I have to do this? This seems really weird. Okay, where's 20 then? I just added it. Sizes? Use that? Maybe I have to close this and open it again. And computers literally never work the way that you want them to. See, it's not there. I don't understand. I don't understand what the point of this is. If I can't use that. I just fix list, adjustable slider. I don't know what these buttons do. Reset sizes? No, I don't want that. I want 20. And I'm going to uncheck that fixed list button. No, that doesn't do anything. What the F? Okay, that is so bizarre. What a weird dialogue. There we go. Okay, that was so weird. I had to like resize this thing. Anyway, there we go. It's 20 point now. There we go. Now it is a better size. I'm happy with that size. It's a good font size. Let's go in here. I updated the README. Nothing particularly interesting in there. Okay, cargo test pass. Let's go in here and let's copy problem 9. Problem 9 is a binary tree. Copy that. Paste. Now we should have, there we go, problem 10. Okay, where's problem 10? I already forget. I have already forgotten what it is. Let's look at the book. Check subtree. T1 and T2 are two very large binary trees with T1 much bigger than T2. Create an algorithm to determine if T2 is a subtree of T1. Okay. So this algorithm is going to involve 2 searches. The first search is going to be to find the let me just change this to is subtree. Just pull all this stuff out. Turn false. I'll just delete this. So yeah, the first search would be to find the basically like the head of this tree. So is subtree, this is a trait, so it'll take an other like this. Yeah, okay. And yeah. Why do I have these? Oh, I use that for my format function, which I don't think I've actually used in a while, but cool, it's still in there. All right, let's delete this, delete that. Let's make two trees, T1, T1, T1. Let me just read the Okay, it doesn't mention also in the problem whether when it says subtree, whether or not the node needs to be the same by reference or by value. So I'm just going to assume it means by value, which makes this problem a little bit easier. I'm just going to do that. Okay, T1, T2. I'm just going to make these 2 trees identical because I don't care. Although really doing it by value doesn't make sense. Maybe, I think for this problem it would make more sense if they were references, but since the problem doesn't specify, I'm just going to do it by value. Although really, like, whether you do it by value or by reference is it's not really going to make that big of a difference in terms of complexity, but I would have to change the structure of my tree because right now it assumes ownership of the value. So I couldn't have that thing, and I'd have to change this to some type of reference, basically. I don't want to change that, so let's just leave it. All right, all that runs, we're good. So here I should be able to say, yeah, assert equal T1, no, this would be T2 is a subtree of T1. This should be equal to true, It's not, it's going to return false because I hard-coded it. Oops. That should be a reference. Boom. Okay. So that's returning false. We're good. Let's implement it. So this is basically going to test if this tree is a subtree of the other tree. Okay. That's it. Now, in order to do this, we have to implement a search to find the head node of this tree within the other tree. So let's just do that. Find head, call it find head. And I'm going to copy the pattern here, basically. Copy this, but copying the pattern I used for this visit. We'll call this find head. Yeah, okay. I'm gonna need to change this function signature, but let me just make sure it's doing what I want. So find head is going to search this, whatever this tree is, starting from this node. Yeah, that could be a node ref like that. And if it finds, we'll say if it finds the head, it will call this function with the node at the head. Yeah, that'll do it. That'll do. That'll do nicely. So this does require an exhaustive search. Well, okay, maybe it could be optimized. Like if you knew the height of the tree or something, you wouldn't have to search beyond a certain depth. But then you'd have to calculate the height ahead of time. You might as well just do an exhaustive search. Unless you have some optimization, or like you keep a cached, or not a cache, but like you update the height of the tree as you build it out or something like that. But you know, those are all optimizations. I'm not going to do any of that. So this needs to be an exhaustive search. And yeah, so what we would do here is say, so let me pass in the head node here, head. This is going to be head node ref t. So this is the head for this tree. I need to restart RLS again because it's fucked up, I think. Fix formatting. Cargo format. There we go. Okay, just commenting this code out for right now. Is Subtree, yada yada. Okay. Excuse me, burp. So if some head equals self dot head as ref, sorry, if let, then okay, then we would call find head. And what should find head return? I think find head should basically return this. Yeah, return whatever this is, the value of this function call, f. Yeah. We'll go back to that. All right. If let some head blah 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 find head self.find head. So this is the head, and then also need the head of the other tree. Yeah, so I actually need both here, and let some call this other head equals other.head.asref, like that. Can I do two if lets? No, doesn't look like I can. That would be sweet if you could, but I can't. I need both of them in order to do this search. Otherwise, false. That's fine. That will fall through. Yada yada. Okay. Find head, head, other head, and then we'll call this root node or something. That'll be the root node of the other tree. And then if I reach this point, then I would call, so this should return a Boolean. This should return a Boolean. So if I reach this point, then I would call the, I would call another function. I would say self dot, I'll just say trees equal or something, root node, and that's it. So I need to write that function, or at least define it here. We'll call it trees equal, does not take a closure, doesn't need to. We'll call this other head, sorry, we'll call this head and other head, like that. I'll just say false for right now. Here we'll just say false as well, just to make everything compile. And we can just return this like that. Doesn't quite compile. Expected. This should be closure, right? Find head, head, head. This does not need to be a mutable function. It can be a ref, but it doesn't need to be mutable. Just regular, not mutable. Trees equal. This should be head and root node, like that. Sweet. Okay, that compiles. Doesn't pass. Didn't expect it to. It shouldn't. All right. So let's implement find head first. Whoops. Okay, so what find head would do is say if, basically if head borrow data equals node borrow data, then that's it. This is the node I want. So then I would call f with this node. Correction, I would return the value of f with this node. Otherwise, I would say result equal that. This should be the same, should be calling the same function here. Self find head, and then it would be this would not be left, this would be head, and this would be left like that with the function. Yeah, okay. Delete this. That should be fine. Mismatch, okay, that's fine. And then, so here, what I would, let me do a little shortcut here and just say if, basically if not, if that, like do a search here, if that doesn't find anything, then search the right. This is just like a little shortcut, or like, yeah, and then return the result of searching the other side. I don't need this return statement. I can just do it like that. And then if it reaches the end, then false, because it didn't find anything. Okay. Oh no, I do need to have return here. Okay. Let me do this. There we go. That's a little more clear what I mean, or what I intend. That line of code should never be hit, right? Let's do else. What's wrong with my code here? I don't know why my syntax is wrong. I'm super confused. Also, I just realized this is like wrong anyway. This should be like this. Yeah. There we go, that's right. So here, basically if this is true, I want to exit early. And yeah, that's that. Okay. Let me just copy this code and put it down here so that the warnings go away. There we go. Now I should be calling all that stuff using all the code. All right, now how do you compare the two trees are equal? Pretty simple. It's basically the exact same algorithm as this here. So I'm going to copy that I'm going to paste it here. And basically, if either of these don't match, return false. Otherwise, continue the search. It's a little more complicated. Hold on, I gotta rethink this. Okay, so yeah, okay, so if either node doesn't match, return false. Easy, okay. And then here say return true. Then I would say then basically the leaves, or like the leaf nodes, need to be the same in the same state of either side, right? Yeah, okay, so I would do match. Okay, so if this is some left, if this is left, then I expect that the other is also some, right? Okay, so it should be the same. Call this other left. Other head has ref. Left, other left. This should not return though, because I still have to search the right. But I can say if these are not equal, return false. There we go. Okay. Else, return false. If these are not equal, return false. Basically, in any case where it's not what I expect it to be, should be left as ref. I was wondering why that was a warning. We're generating a warning. Okay, there we go. If there's any case where it's not what I expect it to be, then return false. Immediately borrows a wrapped value. Let me do an if let instead. If let sum left equal that. Okay, else return false. Or sorry. The other case then basically I would say return, no, not return, I'd say if other head dot borrow left is sum, okay, then return false. Yeah. Otherwise just fall through. I can make that an else if like that. There we go. Okay. And then now I basically just do the same thing, but for the right. Right. Here I can actually just return this. Like that. I believe that is it. Boom. Done. Test pass. Maybe I should test the other case. Let's add another tree here. T3, 5, 6, 7, 8, whatever. T3, T3. And then I'd say assert equal T2 is subtree, T1 false. Cargo test. Whoops, this should be T3. There we go. Boom. Done. That's it. Problem 10. Problem 10 is done. Let me check the Clippy warnings. No Clippy. Wow. All right, let's push that up to GitHub. There it is. 10 seconds ago. Problem 10. Moving on. On to problem 11. Let's go to the book. Let's see what problem 11 is. I already forget. I know I read it. Oh yes, random node. Pick a random node. Boom. Random node. Focus. Oh, there we go. Oh, focus. No. In focus, please. Make good focus. Camera, make good focus. It's not working. There we go. Random node. You are implementing a binary tree class from scratch, which, in addition to insert, find, and delete, has a method getRandomNode, which returns a random node from the tree. All nodes should be equally likely to be chosen. Design and implement an algorithm for getRandomNode and explain how you would implement the rest of the methods. Insert, find, delete. It says explain how you would implement them. It doesn't actually say implement them. So I guess I don't have to implement them. Maybe I should just do it anyway. Let's do random node first. So in order to implement random, I need to know, I need one piece of information, which is I need to know how many nodes are in the tree. And then I need to effectively assign an index to every node. So in some way, right? And you can either invent your own indexing method that just refers to like positions in the tree, or you can just store some references, which is what I'm going to do. I think that is a perfectly reasonable way to do this. Get random node. And then I can just store some, I'll just store some references in a vector and then just return one. Easy peasy. Copy, paste, problem 11. Let's do it. Okay, I basically have, I have insert, I have find. I don't strictly, it isn't called find, but it's called visit from, plus this, where is it? Find head. This is a find. So I basically have that stuff implemented. But, you know, whatever. Anyway, the like insert, find, delete. I mean, the only thing I don't have implemented is delete, which is pretty straightforward. I guess I'll put it in, but I'll do it after. Let's do the get random node first. Okay, get random node. This is going to take in self, and it just returns a node ref. It's really easy. Excuse me. Okay. So I'm going to use this visit all function right here. Copy and paste that because it's all set. It's all ready to go. Nodes. So I'm just going to make a vector of node refs and initialize to an empty vector. And then nodes push I gotta delete this code down here. Oh yeah. Okay, Rust, choose random rec. There should be a function that just like does a choose. Perfect. Extern create rand. Well, that's super simple. I need to include this guy. Whoops. Rand equals, what is it, 0.3? 0.6, yes, is the latest. Use that. And then there we go. That's super easy. Super easy. Doesn't compile. That's cool. Unwrap. I need to clone that. There we go. Boom. Why do I have a red squiggly? Deprecated use sequence slice random. Okay. Maybe this Stack Overflow response is out of date. Oh, I see. I see. Okay. It should just be like that. Boom. Okay. And then how do we assert equal on a random choice? I guess. I'll just do vector 1, 2, 3 contains, and then t1 dot get random node dot borrow data. Sure. All right, there it is. That was easy. Call that there to make sure there's no clippy, unclippy. All right. That's problem 11. Should I bother doing delete? No, I'm not going to bother. Okay, problem 12. Let's move on to problem 12. What's problem 12? Let's take a look. Problem 12. Paths with sum. Right here, problem 12. Focus. Paths with sum. You were given a binary tree in which each node contains an integer value, which, why can't I just ever make it focus? The stupid camera is garbage. Please focus. Contains an integer value which might be positive or negative. Design an algorithm to count the number of paths that sum to a given value. The path does not need to start or end at the root or a leaf, but it must go downwards, traveling only from parent nodes to child nodes. There we go. Now it's in focus. All right, I just read those words, but I didn't really understand what I read there. So let me try to read this again. You're given a binary tree in which each node contains an integer value. Design an algorithm to count the number of paths that sum to a given value. Count the number of paths that sum to a given value. Okay, so this is like again, this is another search problem, and it is a brute force search. So you're given blah blah blah. Count this. Path does not need to start or end at the root or a leaf, but it must go downwards. That makes it tricky. So if it always started at the root and ended at a leaf, that would be easy. But it's basically suggesting it could start and end anywhere. So I think this problem can be solved by applying a little bit of dynamic programming, because basically if you can design the algorithm such that it works for a subset of the tree, then it'll also work for any larger tree just by applying the same algorithm recursively. Okay, let me think about this. Drinking tea in a Starbucks cup. It's the Starbucks lady there. She looks a little weird in that one, a little goofy. Doesn't she look a little goofy? I think so. Her face is kind of wonky. Okay. Let's go to the code. Problem 12. Let's copy 11, paste on problem 12. I realize that my test names going back in history are probably not updating them every time. Right, like problem 11 should be get random node, and problem 10 is what is subtree. Test is subtree. Let's just go and fix these right now. This one is get BST sequences. This one is what? Test find path, common ancestor. This should be common ancestor. Test find path. I guess find path is fine. This is the dependency one. Whatever. No. Let me change it. We'll just say test dependencies. There we go. What else is balanced? Balanced. Is that what I'm testing here? I don't think that's what's being tested. Assert equal. Maybe that is what it's being. Okay, I don't remember. Whatever. Moving on. Check balanced. Oh yeah, okay. So this is checking that they're balanced. Yes, okay. So this should not be check balance. This should be, what is this? This is problem 6. What was problem 6? Successor. Check find successor. Okay, problem 4. Check balanced. Yeah. Problem 5. Oh, this is check is BST. is BST. Yep. This is checking if they're balanced, and then this one is getting the height or something, right? Oh no, this is a list of depths. Problem 3. List of depths, yeah, minimal tree. List of depths. And close all these tabs. List of depths. This one should be minimal tree. And there's C's. 2. Excuse me. Excuse me. Oh, what was this one? I forget. Minimal tree. I think when I sneeze, like, a portion of my brain cells die. I probably lose about 20 to 30% of my brain cells every time I sneeze. Problem 1 is route between nodes. Find path, let's rename that. Route between nodes. Okay. Let me make sure that my tests still pass. Nope, I effed it up. Messed up number 3. Fix test names. Push that up to GitHub. If you're new to the stream, thanks for dropping by. Welcome. Hello. Hello everyone out there. Hope you're all having a nice Sunday. It's a beautiful day here in New York. It's a little chilly. It's about 1 degrees, 2 degrees, I think, or I don't know. Maybe it's warmer. Let me see. Let's look at the weather. Oh, I guess it's warmed up. It's 7 degrees now, but it's kind of chilly this morning. It's nice and sunny out. Sun's shining, which is good, I think. It's good for the vitamin D. Get you some vitamin D. Apparently vitamin D is overrated though. That's the latest news. So I think people overestimated the value of vitamin D supplements. Okay. Paths with some, you're given a binary tree in which each node contains an integer value which might be positive or negative. Design an algorithm to count the number of paths that sum to a given value. The path does not need to start or end at the root or leaf, but it must go downwards, traveling only from parent nodes to child nodes. So this is tricky because of what it says there, the negative values. If you're doing a sum and you knew that the values would only ever increase, then you could stop early. But because you can have negative values in the tree, it also doesn't say binary search tree, it says binary tree. Because you can have negative values, it means you have to do an exhaustive search every time. I don't think there's any shortcut to that. Yeah, so here we are, another search algorithm. Algorithm. It's really not that different from the other ones. Let's do it. Let's delete this stuff. Let's delete is subtree. Let's delete find head. Let's delete trees equal. Okay, what is this problem called? Paths with some test, paths with some. Okay. I wonder if there's a trait for isNumber. Rust number trait. Trait for numeric functionality. You can use num or num traits create. Okay. Let's use this guy. Sweet. Okay, let's add the trait. T num integer. That image on my site? Which one? I have many images, but yeah, thanks. All right. Num traits. I have up till right now, up to the last problem, basically avoided using any external crates, which was, oh, the one zooming, yeah. It may not be totally apparent from that photo, but I believe there is a booger coming out of my nose. Yes, there is, which is part of the fun. I hope that most people don't notice it, but once you see it, you can't unsee it. What can I say? I'm just human. I am but a mere mortal. I need the number trait on the print thing. I think I am kind of getting bored of my website. I think it may be time to just do a redo, start fresh. Also, there's a bit of an Easter egg if you click on this hello thing. You have to click it repeatedly. There's a couple other things in there, but anyway, it's mostly pretty crap. I find it entertaining, at least. Okay, cargo test. All right, what are we trying to do? What is this problem again? Paths with sum, right. Count the number of paths that sum to a given value. So, yeah. Have to do an exhaustive search, and sum, and then every time the value is equal, then increase count. So this isn't that bad. It's just another depth first search. Like, it's order n. It's no worse than order n. It's not like you have to count multiple times, but anyway, okay. So let's add a test case here, assert equal T1 paths with sum 1. What sums to 1? I don't know, probably 1 path. Let's make this tree slightly more interesting. Let's add 1 multiple times, and let's add a -1, something like that. Okay, let's add paths with sum. paths with some, should take self, sum, I32, this is a count. I'll just return I32, whatever. Okay, something like that. And then an inner function here, pass with some inner self node ref t return I32. Okay, so if let some head equal self.head as ref, pass with some inner head else 0. Sweet. Okay, that compiles. This needs one more parameter here, which we would call I'll just call, I'll call this accumulation. This is the accumulation up to this point, basically. So that'll start as 0. Okay, and then here I will say let mutable number of paths equal 0. And then I will say if so if this node's value, node borrow data, so if that value equals the sum, oh, I need to pass this sum through as well. Sum accumulation, sum I32, like that. So if that equals the sum, then paths plus equal 1, one additional path. And then I go through and I basically visit these guys and add the result of those. So instead of parent node, this is just node, this is just node. Delete these, delete these. Calling this function with accumulation accumulation plus, I should say new sum equals this value. There we go. And then if new sum equals the sum we're looking for, one additional path. Okay. Sum, new sum. It should be right, and this should be left. And paths plus equals that. And then return paths. That's it. No implementation for I32 plus T. Why? Can I just cast that to an I-32? Cannot add T to I-32. Std ops, whoops, ops add. There we go. That didn't work. Std ops add T is not implemented. Where I-32, oh, I see. Where was it? Where I-32 std ops add T, I see. Where? Like that. Std compare partially equals might be missing for let's see if I can do this an easier way. Let's undo that. Let's undo that. Undo that. Let me just take let's just do this. Value I-32 equals node.borrow data. Let's call this node value. Why can't I just cast it like that? As can only be used to convert. Use from trait. Oops. Rust num per trait. Can I just use this guy? Let's try this from primitive. No, that's not what I want. Okay, let me just make this not generic. And then I think this will be easier. There's really no reason why it needs to be generic. Basically just get rid of the T. Just make this a concrete type. Node ref, node data, I-32. That's it. Value I-32. Let's get rid of all these. don't need these wheres. Don't need these. Oops. I don't need to specify the type. There we go. Sweet. Paths that sum to 4. Is it 1? It should be, let's see, how many paths do we have that sum to 3, for example? If I move that up, then we should have a couple. No, that's not right. Something's wrong in my code here. Paths. Paths plus equals 1. Left, right. Sum. New sum. Should be more than that. All right, I've got 2, 1, 3. How many would sum to 3? So 2 plus 1 sums to 3. No, I think I need to have paths with sum 3. So 2 plus 1, there's 1. Then 2 plus 3 is 5. 5 minus 2, that should be another. Right there. I don't think it's putting this where I want it. If I do minus 1, no. Either my algorithm is wrong or I'm doing something wrong here. Some head, pass with some inner. So paths, head, 0. Let's change this to new ACK accumulation, just to make it more clear that these are what these mean. Paths with some inner. Let me just print out this tree to make sure that it's doing what I think it's doing, because I'm not sure it is right now. Cargo test. Oh, I don't think that's gonna sum the way I want. So 2 plus 1 is 3, minus 1, 2. There you go, that returns a 2. 2 paths. Now we're talking. Let's see if I can get another number that gives me 2 paths. Yeah, that shouldn't be 2, that should be 0. So 3 is not going to work. How about 4? No. There we go. Okay, yeah, 5 works. There's 2. Huh. Oh, also, I just realized my algorithm is wrong because it says count the number of paths that sum to a given value. The path does not need to start or end at the root or a leaf. Yeah, that's right. But it must go downwards. Forgot. So I actually have to do this slightly differently. I can mostly use this, but I have to reset the accumulator here each time. So do like this, and then add to it once more with the same search, but reset the accumulator like that. Yeah, now we're talking. It's what, 133? Yeah, sum to 2 9 times. That's right. That seems right. 9 different ways. Sum to... I have the same value repeated. So it should sum to 1, 2, 3, 4 plus 5 ways, right? 15. How is it 15? That seems insane. Sum to 1 15 ways. I don't think that's right. It's -1 plus 1. -1, yeah. 1, -1. That sums to 0. 2 plus -1 is 1. Should only be like 5 ways. Paths plus equal. I suppose every time 1 occurs, that counts as, so it's 1, 2, 3, 4, 5, and then plus all these combinations. I still don't think that should be 15. Seems like too many. Yeah, so if these values are equal, so this will be, for all the cases where this is 0, that would be 1 path with the number 1. So it would be Like that's one path, so there's like a minimum of 4 because I have 4 ones. Left 15. How does it get to 15? That seems like way too many. I mean, it could be right. I would have to like write it out manually to figure it out. I am like I think I'm possibly making a mistake in here. So sum should never change. That's like the target value. Head sum, the initial accumulation is 0. Start at 0, start the head node, looking for sum. Basically there's no path until we find an accumulation, which is equal to the sum. And the accumulation is just whatever the previous accumulation was plus the value of this, the data at this node, yeah? And, okay, path is always initialized to 1. So if these are equal, that's one path right there. Found a path. If there are any paths in here, it's another path. I mean, it has to be right. This is a crazy number of paths. 15. I don't understand how there can be so many. But I don't see any logic errors in there. Well, whatever. Must be right. If the unit test passed, then code works, right? Right? What did I change on problem 11? Oh, I didn't even add problem 11. Whoops. Okay, let me add problem 11. Check that in. I need to add this guy too. Git commit. Add problem 11. Let's add problem 12. Let's push that up to GitHub. I should have run Clippy first. Let me run Clippy now. I might have some errors in here. We'll find out. Ooh. Dead code. Method is never used. Oh, yes, okay. Fix Clippy warnings. Push that up. Well, that is it. That is it for chapter. That is it for chapter 4. Why don't we take a little 5 to 10 minute break? I'll come back and maybe we'll do the we'll do 1 or 2 problems in chapter 5. Keep moving. All right, let's take a little break.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
major event coming up with side booster shutdown and separation.
Inside shutdown. Side boosters beacon. Center. Cruise is halfway there. Cruise southward up.
9, 8, 7, 6, 5, 4, 3, 2, 1.
We're back. I'm still chewing. Eating nuts. Sorry. Had a snack. Hanging out here with Doge. She's napping. Come here, pup. Come here. Come here. She's huge. We we went to the we went to the vet this morning. She weighed in at 37.5 pounds. You can believe it. She's like probably the biggest Shiba in the history of the world, I think. Possibly. Anyway, she's huge. I can't believe it. She was the runt of the litter. She was just a little tiny thing. Now she's giant. I think she's gonna have to go on a diet though. Now I'm covered in fur again. She's very furry. I'm very furry. I'm always furry because she's furry. We're just a furry pair. That's the way it is. So, welcome back. Thanks for tuning in. Thanks for sticking around. We're cracking the code interview. We just finished chapter 4. We're in the book, doing the book. Just did chapter 4, all done. We're on to chapter 5. Chapter 4 was trees and graphs, and chapter 5 is bit manipulation. So that's what we're on to. There are, how many chapters are in the book? There are 17 chapters. 17? Yeah, 17 chapters. Although judging by the pages, judging by the thickness of the pages, so this is how much I've done here. And this is how much is remaining, that much. And if you just compare those thicknesses, if you can see it, that's what's remaining, that's what we've done. It looks like I'm actually past halfway. I don't know what portion of the beginning. Yeah, I guess there's like a pretty, anyway. In terms of number of problems, how many problems have I done? Let's look. Let's do a little count. There are 189 total problems, and I've done I should share my screen. Excuse me. Source bin, word count -L. I've done 35 problems. 35 of 189. That means there are 154 problems to go. Am I doing math right? There's 100. If there's 189, that doesn't seem right. It seems like the numbers are off. Wonder if there is some sort of counting trickery going on, or if there are just a lot more problems in the following chapters. I'm just scanning through them right now. Some of these chapters have a lot of problems. Oh, I see. Okay. So it looks like from chapter 16 and chapter 17 appear to have a lot of problems. Chapter 16 alone has 26 problems, and chapter 17 has 26 problems. I guess that's where the problems are. It does look like chapter 16 and chapter 17 are a little more challenging for sure in terms of the problems. Let's just glance through them here for a minute. After some time, the keyboard shortcuts stop working in OBS. I don't know why. It's kind of annoying. A little bug. Let's see. What are some of the hard problems? Longest word. The masseuse. Shortest supersequence. Missing 2. Volume of histogram. Shuffle. Shuffle a deck of cards. I've been given that problem before. There's a little trick to doing the shuffle. There's sort of a naive way that most people try to do. But yeah, there's a trick. I don't remember the trick. I think if I think about it, I would remember it. But anyway, okay. These are stupid problems. So never give anyone that kind of problem. Although, like, I remember when I was like 22 or something. I think I was like 22 years old. I interviewed at Amazon, and I remember the guy gave me this card shuffling problem. I remember that. And I actually knew the correct solution, and I gave him the correct solution just because I happened to have studied this particular problem right before, and I remember it. Anyway, they still said I wasn't good enough though. I didn't shuffle the cards well enough. Insufficient shuffling. All right, let's take a look at chapter 5. That is where we are. Chapter 5 is about bit manipulation. Cool. I'm just looking over the code really quickly. Some of these problems are not actually coding problems. Like, for example, there's one here, problem 5. It says, the problem is called debugger, and it says, explain what the following code does. So I guess that is not really a problem. Like, I'm not gonna write a test for that, because, you know, I mean, I guess I could write the code. I could put that into some code, but it seems kind of pointless. Okay, so let's do it. Let's get into chapter 5, problem 1. Chapter 5, Insertion. You are given two 32-bit numbers, N and M, in 2 bit positions, I and J. Write a method to insert M into N such that M starts at bit J and ends at bit I. You can assume that the bits J through I have enough space to fit all of M. That is, if M equals 10011, you can assume that there are at least 5 bits between J and I. You would not, for example, have J equals 3 and I equals 2, because M would not fit between bit 3 and 2. Okay, I think I get it. This is a really stupid problem, but whatever. What is it? It says insertion. what is also like the concept insertion when it comes to bits doesn't even make sense. You can either AND bits or you can OR bits. Well, whatever. Let's do it. This looks really trivial, frankly, to implement, but let's do it. Okay. So I'm going to copy the last problem here, paste, paste, and then I'm going to rename this file chapter 5 problem 1, and then I'm just going to delete all this code pretty much. Okay. Test insert bits. Is that what it was called? Yeah, we'll just call it insert bits. I'm gonna delete all this. I'm gonna clean out main, cargo test, and cargo test. That should compile. And that's it, right? Right, Doge? She's asleep. Little cutie pie. Little cute turkey. She's such a furry little cuddly turkey. She doesn't really cuddle. She doesn't like cuddling. She's very furry though, and she's definitely a turkey. Real big turkey. She's such a goof. Oh, I just boiled some water to refresh my tea. Let me go do that. I'll give you the full screen experience while I refresh my tea. I'm drinking tea. This is original Irish breakfast black tea from Trader Joe's. It's not actually, Trader Joe's doesn't actually make anything, so it's made by somebody else, but it's branded as Trader Joe's. That's their model. I'm just adding some fresh water, freshly boiled hot water. I'm not actually adding any more tea. My cup was like half full, so now it's nice and hot. Well, hotter, not that hot. I don't like my tea like piping hot. I like it warm. Like, I like it between hot and lukewarm, kind of like warmish. I don't like it really hot though. All right, computers. Let's do computer stuff. Hell yeah, computers! Woo! Woo, computers! Woo! Insert bits. You are given two 32-bit numbers, N and M. A 32-bit number. Function insert bits. In 2-bit positions. Write a method to insert M into N such that M starts at bit J and ends at bit I. Okay. Such a weird problem. What were the arguments? N, I32, M, I32, I32, J, 32. R times I32. So I don't know why I and J, this is so stupid. This is such a weird way to think about this problem. Assume that there are at least 5 bits. You would not have, so basically it's saying like the input is valid, blah, blah, blah. Between bits starts at bit j and ends at bit I. I don't know why you even have this j here, but basically right, let's do this. So mutable return value is going to be it's going to be this I and j thing is super confusing. But basically we're taking m and we're shifting it by I bits, and then setting those bits to whatever that value is on n, right? So let's start there. So for derp in range of basically 0 up to I, this equals 1 shifted, should be or equals, yeah, 1 shifted by whatever. Yep, just like that. Okay. And this gives us I suppose it's not that simple. Okay, this should be j minus I. Okay, and then is that right? Or why don't I just do this from, I can basically just go from I to up to j. Introduce a new single letter variable. Okay, return equals 1 shifted by x. Yep. So this should give me just make this function return that. Let's just run this and just see what I'm getting here. Rust print line format. Is there a way to format as binary or something? Sweet. That is what I want. It's got it all. Rust lang, cargo test. I need to actually call this function. So how do I Rust binary? Can I do 0b? Does it understand that notation? I don't know. Just call this function. So what is n in the example? N is 0b, 1, 1 followed by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then M is 0, 0B, 1, 0, 0, 1, 1, 1, 0, 0, 1, 1. And then I and J are 2 and 6, 2, 6. Okay, insert equals. I'm just copying the example basically straight out of the book. It's going to be that mostly with 1, 0, 0, 1, 1. Like that. Is that the right number of zeros? No, I messed it up. It should be 1, 3 zeros, and 1, 2 zeros, 2 ones, 2 zeros. Is that right? I think so. My brain is kind of hurting trying to look at that. Okay. Yes. So that is printing out what I want, except this needs to be an inclusive range. So fix that. And now there we go. 1, 1, 1, 1, 1, 0, 0. Okay, perfect. So we take that value and we say to a binary AND of that with M shifted by I bits. Okay, and then finally we do an OR of that with actually this should just be initialized to N like that. Okay, yeah. I believe that is it. Maybe? No. What did I mess up here? Oh, because I'm doing this AND here. AND with yeah. This is going to unset all the other bits. But I only want to unset the bits in this range. All right, so initialize this to 0. Let me make sure that this first part works. Yes, that works. Okay, and then I want to OR this with I want to OR this with how can I do this? I basically want to map here. I think I got a good way to do this. Okay. So let's do it's been a while since I did bit manipulation like this, quite honestly. I'm not muted or anything, am I? Sounds working, right? Should make sure that, yeah, we're good. I think we're good. I think we're good. Okay. Let me call this M. A mask like this. Okay, and then let me call why does it not compile? I found, oh yeah. Let's just return 0. Okay. I don't know why I'm doing this, because it's like not that complicated. So yeah, okay. So let's initialize this to n and then say mutable and mask equals 0. Yeah, like this. Okay, and then and this with the mask, and then or this with m. There we go. That should be it. Nope. What did I mess up? Oh, I need to invert this mask. There we go. Except that's still not right. Good job. Good job, dummy. Wait, what did I just do? No, that's not right either. What am I returning here? Oh, I'm printing out the wrong value. There we go. There we go. Okay, I had it right. Bingo. There it is. Let's check Clippy. Clippy's not happy. Wants me to format this better. Pretty good suggestion. Thanks, Clippy. Appreciate that. Let's just copy this, put it in main, make sure that function actually gets called. All right. Commit, add chapter 5. Problem 1. Push that up to the GitHub. Close these. Boom. Okay. Chapter 2, binary to string. Given a real number between 0 and 1, that is passed as a double, print the binary representation. If the number cannot be represented accurately in binary with at least 32 characters, print with at most 32 characters, print error. Oh dear. Wants me to print a floating point number in binary. Well, all right. A real number between 0 and 1 that is passed in as a double. Print the binary representation. If the number cannot be represented accurately in binary with at most 32 characters, print error. Okay. How peculiar. So we're converting the binary value of a floating point number to a string. Very good. Float bits to string. Return a string and it said double, which means 64-bit float. I don't know what exactly tests float to string. I don't know exactly what it means by if the number cannot be represented accurately. What is that saying? What does that mean to not represent it accurately? I don't know if I understand what's being asked, but whatever, let's give it a shot. I don't really like the way the question is posed. And you can't take a 64-bit float and represent it accurately with any number of bits other than 64, really. I suppose if like a bunch of the bits are 0, then fine. So let's do this. Let's say if I'm going to say if any of the like the upper word is non-zero, then return error. 1, 2, 3, 4. Okay. If that is non-zero, return what does it say? Error. Because I can't really imagine what else it would be asking. Okay, and then loop over the bottom 32 bits, basically, for I in 0 up to 32. Let's go make a string here, let return value equals just an empty string, new. Okay. So this is going to be I'm going to append to the string, Rust string. Please tell me there's an append method. Push, yeah. Push. I'm either going to push a 1 or I'm going to push a 0. And I will push a 1 if 1 shifted by 32 minus I bits, ANDed with n. If that is true, push a 1. Otherwise, push a 0. And then return the string. Oops, try to test. So what, I can't do binary operations like that on a floating point number in Rust? Rust floating point bitwise operations. Two bits. Maybe I need this. 2 bits? Oh, I see. Okay. One F4. Got it. Let's try this. Let bits equal and 2 bits. Bits. If one shipped by blah blah blah, this is non-zero. This is non-zero. This should be mutable. Okay. I don't know if this is really gonna work. Doesn't make a lot of sense to me, but let's try it. Start equal float bits to string 0.72. Yeah? I don't even know what the binary representation is, so let's say 1. Say 0B1. Oh, sorry, it should be 1. That should be a string. Error. I guess it can't be represented with 32 bits. I'm guessing because it's using the upper part of the word. So let's do this. That doesn't work either. Let's just print this out. What does that print? Well, there's no way to represent that with 32 bits. Jeez. If the number cannot be represented accurately in binary with at most 32 characters, I'm just gonna ignore that that at most 32 characters bit because it doesn't make sense. And I'm going to go ahead and print out the entire string like this. What did I do here? I think my order of operations is off here. Right? 64 minus I. I see. This has got to be 63. There we go. Left. Yeah, that looks good. Beauty. So this question doesn't really make any sense, but whatever. Let's add it anyway. Git add. Whoops. Git add dot git commit. Chapter 5, problem 2. And it could just be that I'm too dumb to understand this problem. I should have checked Clippy first, but yeah, I don't know. Regardless, I did a thing. Perhaps I will realize later why it is wrong and come back to it. Whoops. Commit the Clippy stuff. There we go. I'm getting tired. It's like afternoon nap time. Batteries are running low. Okay. Did it. 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 How are we doing here? Is my build still passing? I imagine it is. It should be. Let's look at the book. Let's go to the book. Go into the book. To the book. What's the deal with OBS? What's the deal? Okay. Flip bit to win. Flip bit to win. Please focus. Please camera, there we go. Flip bit to win. You have an integer and you can flip exactly 1 bit from a 0 to a 1. Write code to find the length of the longest sequence of ones you could create. Input 1775. Output 8. You can flip exactly 1 bit from 0 to 1. Longest sequence of ones. Find the longest sequence of ones. So basically what this question is asking is find the longest two sequences of adjacent ones. What is the trick? What is the trick? What is the trick? Flip it to win. Okay. Let's put these on. Copy problem 2, problem 3. Couldn't you just look at the sum of 2 adjacent blocks of 1? Yeah, could do that. I think, yeah, my initial thoughts on how to implement this is to basically count adjacent ones and then just use like a Boolean or something and allow one non-1 value and then just, yeah, basically sum up all the ones that I find, and then just repeat that algorithm until I'm just like try to find the biggest whatever. I also think that the way to do this is to search for the pattern of 101, right? Basically just like look through the whole bit field and just try to match 101. Although you could also have the case where it's like it's all ones, right? It says you have an integer, you can flip exactly 1 bit from a 0 to a 1. Write code to find the length of the longest sequence of ones you could create. So if it's all ones, the longest sequence of ones is just the whole thing, right? And yeah, okay. What do we call this? Let's call this, this is called flip bit to win. Okay, test flip bit to win. Oh, what a weird name. So function flip bit to win takes in, I guess, a 32-bit integer probably. Let's call it n, returns a 32-bit integer, and yeah, doesn't really say much else about the problem. Okay, so if I have, let's just write some test cases here. If I have a number like, say, 11011, I should return 5. Would not work if there are 2 or more 0 between blocks of 1. Right, so in the case of 110001, yeah, that should return 2. Let me write that test case right now. All right, that would be 110001. That would return 2. So yeah, basically I just want to count the set bits. Should return 3. Oh, that's right. Yeah, you're right. Good point. Okay, so I want to count the bits that are adjacent and then tolerate 1, whatever. So basically all I have to do is like apply this algorithm and then like do this count and then shift it by 1 every time. And then whatever the maximum value that I find is, that should be it, right? Okay, so return value we just initialize to 0. And basically I can yeah, I would just run, basically just like iterate over the whole thing. So I just do for I in 0 up to 32, right? And then I just say let mutable bits equal n shifted by whatever I is. Yeah, and then I'd say, and then I'll just have a boolean and say like let mutable bool flipped 0 or something equal false. Okay, And then I just want to count the ones, basically. Less mutable ones equal 0. And then I'd say while basically as long as I haven't flipped this 0 value, then I can say as long as I haven't flipped this 0 value and my bits is not equal to 0, I'll just say ones plus equals 0x, or just 1 amp and ended with the bits like that, right? I'm usually just counting the rightmost bit, and then I'm going to shift the bit field by 1. Whoops, shift it the other way. 1. Okay. So that's the case where this bit is a 1. So the other case would be basically if this is equal to 1, do this. Otherwise, actually, I'm going to do this no matter what. In both cases, I'm going to do this no matter what. I actually only need to do this if this is equal to 0, right? Yeah, whoops. So if this bit is 0, then I would say flipped 0 is true, and then continue this, basically. No, this isn't quite right. This should just be while bits, yada yada. Okay, so this should be if this is equal to, so if I have already flipped the 0 value, then at this point break out of the loop, and otherwise, yes, okay, there we go. I think that's right. And then at the end here, I would just say, code is messed up. I'm missing private formats. Oh, that's not valid code. There we go. And then at the end here, I would just say the return value is just going to be the maximum of Rust int max. No. How do I, what's the, no, that's not what I want. Rust max function. I assume there's there we go, compare max. That's what I want. SCD compare max. So this is just going to be whichever is larger, either this count of ones or one previous ones. And that is it, I think. Nope. Something's wrong. Flip it to win. Oh, this should just be ones plus equal 1. Yep. There we go. Boom. Well, that's it. That's pretty easy. Let me just copy this code, put it into main so that Clippy's happy. Clippy is very pedantic. All right, that is problem 3. Push that up to GitHub. Let's take a look at problem 4. Problem 4, next number. This is called next number. What does it say? Given a positive integer, print the next smallest and the next largest number that have the same number of 1 bits in their binary representation. Given a positive integer, print the next smallest and the next largest number that have the same number of 1 bits in their binary representation. Okay. Given a positive integer, next smallest and next largest number that have the same number of 1 bits in their binary representation. Let me think about that. The next smallest and the next largest. Okay, let's copy problem 3, paste that, problem 4. Okay. What's this problem called? This problem is called next number. Next number. So a function that, given a positive integer, next smallest and next largest number, next number, n I32, and it should return a tuple of integers like that. Okay. So what does this mean? Next smallest and next largest number that have the same number of 1 bits in their binary representation. So how would I implement this? So if I have a number like the number 2, yeah, the next smallest and next largest numbers would be 4, right? And would be 1, I believe. Those have the same number of 1 bits. And I calculated that simply by shifting that bit. But if I had another example, if I had close that tab. If I had, let's just say I have this number. What would that be? So the next the next number that would be smaller. I don't think you can have a smaller number. Well, hold on. There would be, so 1 would be 1, 1, 1, 1, 0, right? That would be the next larger. That has the same number of bits. But how could you have a number smaller than that that has the same number of bits? My understanding of this problem, the next smallest and the next, oh, it doesn't say smaller or smaller, it's the next smallest and the next largest. What does that mean? Next smallest and next largest. Next smallest and next largest. So like, what is this? This is brain's not working. This is what, 15? Yeah. This is 15. So the next smallest with 4 ones. What does that mean? Does that mean this is the next smallest? And then what does next largest mean? Next largest? This question doesn't make any fucking sense. Given a positive integer, print the next smallest and the next largest number that have the same number of 1 bits. Next smallest and next largest. I don't understand what the hell that means. I mean, if I have a number like this, basically all I can do is shift bits to the left, right? One way or another. Maybe not contiguously, but what does next largest mean? Does that mean add 1 to the number, or not 1, but and you can shift all the bits, or you can shift just 1 bit. Like you could have 0B 1 0 1 1 1 or something, but like what does that even mean? I don't know. Is that the next smallest or is that the next largest? So these are basically, I think these are like the 2 options here. Strictly, there are more options like that. Right? Is this making sense to anyone else? It's not making any sense to me. I want to just look at the Java solution to see what the hell this question is asking, and then maybe solve it. I suppose if this were an interview, I could ask clarifying questions, because the way this question is phrased just doesn't make any sense. Given a positive integer, print the next smallest and the next largest number. Okay, I think I might understand what it means. So, like, if I have 5, what would be the next number less than 5 that has the same number of bits? And what would be the next number, or the same number of ones, and what would be the next number greater than, yeah, okay. I think I understand it now. It's just like worded weird, but this should be pretty straightforward. So basically, it's really easy. So smallest, let's call it next smallest, equals 0, mutable, and then let mutable next largest equals 0. Like that, right? Okay, and then basically I will say for I in n up to n up to I32 dot, how do I get like the integer max value? Rust int max. std like that. I don't actually do that. Let me just make a new variable and use that. Let mutable c equal n, and then I'll just say while c is less than std I32 max n plus 1. Okay, and then I need to count the number of bits, so let me just write a function to do that. Count bits I32, just return another I32, and then basically just say while n is not equal to 0, if n and 1 are, rather, need a count, mutable, let mutable count equal 0. And count plus equals n and 1, and then n shift 1. Return the count. That should be it. Okay. That will count the number of ones. So let 1 count equal count bits. I should say count ones. Let's change that. Count ones. I'll return the number of ones. Okay, so if count ones of c is equal to the 1 count of n, then next largest is equal to c break, right? That's pretty much it. And do the exact same thing but count down. And while c is greater than 0. Oh geez, thank you. I very frequently forget to switch it. I'm really bad about that. Okay. Welcome, by the way, to the stream, Malikin lol. Okay. Cargo format. Count 1c, next smallest. Okay, c minus equal is 1, and then c plus equals 1, right? And I think that's pretty much it. I don't think there's any way to do this either than like brute forcing it. Cool. So let's write a test. Assert equals next number suppose I have a binary 1, 0, 0, then I should get, the next smallest should be 0b 1, 0, and then the next largest should be 0b 1, 0, 0, 0. Boom. I believe. Cargo test. Oh dear. That should be uppercase. Oh dear. My loop's not breaking out here. I32 max. Which loop is not breaking out of? Let mutable count equals 0. Count plus n. Yeah, that looks right. While C is less than int max, right? And is this what I think it should be? Whoops. Largest value that can be represented by this integer type, naturally. So if C, oh, I need to reset C here. After this, I should say C equals n minus 1. There we go. That wasn't the problem though. I wonder if it's just like super slow. That can't be it. I'm just gonna comment this stuff out and then make sure that my count ones, oh, it looks like my count ones is the problem. While n is non-zero, right? Oh, this should be, there needs to be an equal sign there. Okay, my bad. I was doing a bit shift here, but I wasn't like reassigning the value. Does that not work in Rust? N equals n shifted by 1 bit. Oh, I can't. Okay, mutable. Just call it temp. There we go. Did it. We're done. Let's put this into main. New Clippy happy. Let's run Clippy. Of course Clippy is going to tell me that I should use this instead of that. What? There we go. Okay, cargo test. Let's add that. Problem 4. Push it up. Push it up to GitHub. Problem 5. I'm not actually going to do problem 5 because it's stupid and it's actually just, it's like asking a question. I don't really think there's any code to write. It just says, debugger right there. Problem 5. Please focus. Camera. Please focus. Debugger, explain what the following code does. n ANDed with n minus 1 equals 0. So what does that code do? I've seen this before. I'm trying to remember. Let's think about it. N ANDed with n minus 1 equals 0. So if I subtract 1, let's just write it out. What's happening here? So suppose I have like 0, 0, or 0b. Say I have like 1, 1, 1, 1, 1, 1, 1, like that, okay? So if I take that number and I AND it with the same number, minus 1, then that means that would change to a 0. Okay? That means the result of this would be would basically be all the upper bits. It would be this. That would be the result. Right? So is that equal to 0 in this case? That's what the question is asking. Is that equal to 0? It's not. So what's the other case? If we had, imagine we had like 0b, blah, 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 or blah, 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 0, and it ANDed that with itself. This minus 1 would be 0, 1, like that. Okay, if you ANDed these two, you would get that. Is that equal to 0? No, it's not equal to 0. So what does this tell you? As far as I can tell you, it tells you if the value is 1, right? Unless I'm missing something here. Yeah, as far as I can tell, it's testing if it's 1, because the only case where it will be 0 would be if you really had 0b0 and with no, it tells you if it's 1. Oh yeah, because if you ANDed these two, if you did that, and that would be equal to 0. That's equal to 0. So I guess it's telling you if it's 1, as far as I can tell. Or does it have also something to do with 2's complement? I don't think so. Okay, well, whatever. Let's move on. Problem 6, conversion. Write a function to determine if the number of bits you would need to flip to convert integer A to integer B. Write a function to determine the number of bits you would need to flip. Okay. So show you this problem. It is right here, conversion. Focus. Come on. Please. There we go. Conversion. Write a function to determine the number of bits you would need to flip to convert integer A to integer B. Is this as simple as doing an exclusive OR? Let's see. Let's write it out. So, copy problem 4, paste, rename, become problem 6. Let's delete these, delete that. What is this called? Conversion. Test conversion. Conversion. Delete this. So we're looking for number of bits you would need to flip. Okay. So how many bits are needed? The example in the book is going from 0B 11101 11101 to 0 11111 11111. It's too many ones, right? So you'd convert 2 bits. So also if I XOR these, I would get 0B, I would get 1 0 0 1 0, right? Which also gives me the number of bits. So I think all you need to do is do an exclusive OR and then count the bits. So let me copy count ones from this one because I can reuse that. What are we calling this? Conversion count, I'll say. A, I32, B, I32, turns an I32. Okay, I would just say let XOR equal A, exclusive OR with B, and then just return the number of ones, right? I think that's it. Assert equal, conversion count, 0B, what's the problem in the book? 11101, 0B, 0 11112 should be equal to 2. Oh dear, messed it up again. Oops, cargo test. All right, there it is. So this is super simple. Just exclusive OR both these values, then count the number of ones in the XOR. That's it. Okay, copy this into main. Check with Clippy. That's it. Git add, git commit, problem 6. push that up. Okay. There are only 2 problems left in chapter 5. Wow. Just blasted through this. Hello to my new viewers. Welcome, by the way. If you want to follow along with the code, it's up here on GitHub. You can go to my GitHub profile / cracking the coding interview Rust. My GitHub profile is just my name without any vowels. And you can check it out. You can follow along. You can fork it and do the problems yourself if you want. Or you can never look at it again and you know, live your life any way you'd like. You know, you do your thing, whatever that is. Let's make sure this build's still passing. It should be. I think we're good. Check my message thing. All right. Getting some messages, replying to the messages. Build is still going. Pretty sure it's gonna pass. Let's look at the, while that's running, let's look at the next 2 problems. Yeah, chapter 5, almost done. 2 more problems. Next one is called Pairwise Swap. Write a program to swap odd and even bits in an integer with as few instructions as possible. Okay, that one's really easy. I already know how to do it. Draw a line. A monochrome screen is stored. Okay, I'll not do that one yet. Let's do the swap. The swap is so easy. This one kind of annoys me because it's like so easy, but okay. Hold on. Let's take a 1-minute break first. I'll be right back. All right, we're back. Let's do it. Let's do swap. How do you do swap? Bitwise swap. Super easy. I'll show you. So I think I in an earlier video I may have already explained this, but there's this cool trick you can use with when you want to like swap 2 integers or something, where you do it in place. So let's do this. Bitwise swap. If you've been doing software for a while, then most likely you have already seen this. So it's probably not going to be special, but you know, whatever. Let's just pick some random values, whatever. that should return the same things but swapped. It's not really possible to do this in place in Rust, so we're kind of like pretending, but you know, whatever. It's fine. All right, let's implement this bitwise swap. A, I32, B, I32, and then I'll just return a tuple of integers. So how do you do a bitwise swap? You do it like this. So we're gonna need two values. We can't actually do it in place, but we can pretend. All right. So let's call this temp A equals A, and then, oh, you know what? I can do this in place. Why don't I just make these mutable references? No, this is kind of ugly. It is ugly. It's not nice. All right, whatever. Let's try it. I don't know if the compiler will actually let me even do this, but let's give it a shot. Okay, let A equal. Let's do this. Let A equals that. Let B equal that. Okay. And then bitwise swap A, B, and then assert equal. A should be equal to 0B001. B should be equal to 110, like that. Okay. So how does it work? So basically what you do is you do 3 XORs like this. Is it like that, or is it equal? I don't know, whatever, let's do this. B dirt equal A, and then A XOR equal B. Okay. Cargo test. Cannot use on type. Oh, I need to dereference these. Types differ in mutability. Mutable, 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 mutable. Boom, done. There it is. Okay, so what's happening here? I've walked through this before, but let me just, like, using the example I have here, let me just show what's going on basically at each step. So initially A is going to be equal to 0B110, and B is going to be equal to 0B001, right? So after the first step, I'm assigning to A the value of A exclusive ORed with B, right? So when you XOR A with B, what am I going to get? A is going to turn into, it's going to be this, yeah? Because it's this value exclusive ORed with this value. So I'm going to get 1, 1, 1, 1, blah, blah, blah. B has the same value. Then I'm going to repeat the same thing, but flipped around. So now I'm XORing B, or I'm assigning to B the value of these two XORed, which in this case is going to be 0B110, yeah, and then A is going to be the same value, 0B111, okay, and then repeat the process once more. Now we're XORing these guys again, but we're assigning it to A. So A becomes 0B001, and then B has the same value, which is 0B, 1, 1, 0, and then boom, that's it. And yeah, it's pretty straightforward. If you've never seen this before, it's like a popular trick that people like to, you know, do, especially in like interviewing type things. It's actually been a while since I've seen this one in an interview, but there you go. If you ever get asked how to do a swap in place, just remember you do an exclusive OR 3 times, and then you're done. Easy peasy. Easy peasy lemon squeezy. Easy peasy lemon squeezy. All right, one more problem. Let's bang it out, and then we're done chapter 5. Did a lot today. A lot of problems. This one is called an itchy face. This one is called Draw Line. A monochrome screen is stored as a single array of bytes. Okay. I have a really itchy face. Single array of bytes, allowing 8 consecutive pixels to be stored in 1 byte. The screen ends with W, where W is divisible by 8. That is, no byte will be split across rows. The height of the screen, of course, can be derived from the length of the array and the width. Implement a function that draws a horizontal line from x1, y to x2, y. The method's signature should look something like that. Okay? Draw a line. Single array of bytes, allowing 8 consecutive pixels to be stored in 1 byte. Got it. This is such a weird problem, but whatever. I think Gail was really grasping at straws coming up with problems for this chapter because these are so stupid, frankly. Okay. So, draw a line. Screen, int width, x1, x2, y. Single array of bytes. 8 consecutive pixels. All right. The way this problem is phrased is, or the way it's just a weird problem. Okay, copy problem 7 to problem 8. What do we call this? Test. We call this draw line. Test draw line. I don't think I checked in problem 7, so I should do that. Let me also just call this function from main. Make sure the compiler clippy and everyone is happy. Okay, let me add problem 7. Yep, that's the right one. And git commit, problem 7. Push that one up to GitHub. All right, now let's solve problem 8. Oh, you know what? I didn't format it. Whatever. Builds can fail, but I'll fix it later. Okay, function signature takes in an array of bytes, which is the screen. A width, x1, x2, and y. Okay, draw a line. Is there like a byte type? Rust primitive types. What are the primitive types? I think U8 is probably the one I'm going to use. Yeah. There's no byte type. We'll use U8. Okay. Bytes. Take a vector. Then what's width? Width 932. These should really be U sizes. Let's do that. U size. Width, U size, and then x1, x2, and y. x1, U size, x2, U size, and y, U size. So what does this problem ask me to do again? I already forget. Monochrome screen is stored as a single array of bytes, allowing 8 consecutive pixels to be stored in 1 byte. 8 pixels in 1 byte. Okay. So it's basically just binary pixels, off or on. Got it. The screen has a width of W, where well, W is divisible by 8. Okay. Height of the screen, of course, can be derived from the length of the array and the width. Implement a function that draws a horizontal line from, yep, okay. Eight consecutive pixels to be stored in 1 byte. Screen has width W. No byte will be split across rows. All right, so basically we're packing a 2-dimensional array into a 1-dimensional array with bits. Can't imagine why you'd ever want to do that, but here we are. I guess if you're very, very low on memory, then maybe you might end up doing something like this. So I'm just going to assume that the bits go in sequence across X. So to go from X1 to X2, I'm just going to assume that's at some particular row. Yeah, okay. So let's see. Basically what I want to do is map, I want to map the bit position or whatever into my vector of bytes. Yeah, okay. So first I would need to get basically get the row. And I would determine the row by looking at the, or not the row, I guess I need to know the row and where that starts in, where the start of the row is in this context, and that's going to be relative to the width, yada yada. Okay, so the height is just going to be the width on, and the width is going to be the number of pixels, presumably. Screen has width W, where W is divisible by 8. Yes. So the height is just going to be equal to the length of this guy times 8 divided by the width, like that, right? Let's just call this function here. So a vector of, I don't know, 0, 0, let's just do 4. Okay, width. Say the width is whatever. Yeah, that's fine. Let's do 16. That should be good. Okay, and x1, I'm just going to say 0, 12, and let's say 2 for y. Okay. Let Did I do that right? There's like a syntax for initializing vectors where, how do I do this? Most vec. I think I'm using it wrong. Vec. Oh, should be a semicolon, or yeah, semicolon. So it should be the value and then the number of times expected reference. There we go. That compiles. I just need to implement this algorithm. Copy this function into main here. Okay. The height and the width. Okay, so I wanna figure out where I start, where the start position is. So let's say let start position equal, it's going to basically be y times the width, right? Y times the width, that's where I start, and then plus x1, and then the end position is just going to be the start position no, it's not. It's going to be y times the width plus x2. Yeah, okay. So because these, do I need to keep track of the height like this? No. Because these values are, these represent bit positions within within bytes in the vector. So I need to go to that, start from that byte position, basically. Right, okay. So that is going to be whatever this value is. So only 4. Oh yeah, I'm going to go 4i in, will be from start position divided by 8 up to the end position divided by 8, and this should be inclusive range. Okay. Actually, no, I should just do this. From the start position up to the end position, like that. That's better. And then here I will say this needs to be a mutable vector, by the way, I just realized. Yeah, because I'm going to be changing these bytes in place. That can compile. Types differ in mutability. I pull this vector out and make it mutable. That same code up here. I will test. There we go. Okay. So 4i and blah blah blah. And basically it will just say bytes where I divided by 8 blah 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 is going to be equal to whatever this byte value is divided by 8 ORed with, I suppose I can use or equals, ORed with, the fuck is going on? Hello Thanos car. I'm writing some code. We're doing we're cracking the coding interview, going through this book. It's called Cracking Coding Interview. Doing some coding problems. If you want to follow along, please do. Code is on GitHub. You can go to my name, Brenden Matthews / Cracking the Coding Interview Rust, You can find the project and check it out if you want. We're on chapter 5, problem 8. And yeah, I just lost my train of thought, so thanks for that. Okay, 1 shifted by, it's going to be I mod 8, like that. I believe that is it. Cargo test. Blew up. Didn't like that. Did not like that. Length is 4, but index is 4. I'm probably passing in numbers here that don't work. Right, width is 16, so I should be able to go from 0 to 12. I don't think I have enough rows in here. Oh, that's the wrong one. There we go. So I'm not totally sure if that worked, but I think it worked. How should I verify this? Let me make it really very small. So this is going to be 8. So that's 8 times 8. Right? Yeah. So let me make this 8. Make this 8. Let's make this row 1. Okay. Put the same values down here. Cargo test. And then let me print this out. Cargo test. Sweet. Is that? Yeah, that's doing what I expect. That's 8 bits, 255. Eight by 8. Yeah, sweet. I think that is it. Let me add an insertion in here, and I think we're done. Zero, 255. Like that. Sweet. That is it. We are done. Problem 8. We are finished chapter 5. I'm going to push that to GitHub. Well, I think that's it. That's it for today. I'm going to make sure that build passes. I might fix it if it's failing, but I think we're done. So here's the book, by the way, Cracking the Coding Interview. If you want to check it out, you can buy it if you want, or you can just look at the problems online, you know, whatever you prefer. I guess if you get some value out of this, it's probably worth supporting the author, Gail. Although judging from her bio here, it sounds like she's a genius and she's probably a billionaire by now because she's so good at computer puzzles, and she's got 1,000 degrees. She's got, yeah, it says she's got 12 different degrees from the greatest schools in the world. So she's probably a total super rich genius and doesn't need you to buy her book, but buy it anyway to show her some support, give her a little ego boost at the very least, and help perpetuate these stupid ass problems and stupid interview puzzles and stuff. Just kidding, don't do that. Stop doing it. If people make you do this stuff at your workplace, if you work at Google, try and stop it. It's stupid. Focus on more practical problems, in my opinion. I think these don't really provide good signal. All right, so why don't we find someone to raid here with the stream? Let's see if there's anyone doing something cool, and maybe we will see what we can do here. Here's someone writing some code. Yeah, let's go raid this one. All right, thank you all for tuning in, dropping in. I found someone to raid. I'm gonna go do that, and I hope that you join me next week. I'll probably be back on Saturday, pick up where we left off, crack the coding interview, and thanks for watching. Bye-bye.